Questions 1 through 10 on the 2019 Grade 10 AMC 10A. What is the value of this expression? Well, let's take a look. 1 to the power of 9 is 1. 0 to the power of 1 is just 0. So this is just 2 to the power of 0. Here we have 2 to the power of 0, which is 1. And then 1 to the power of 1, and then to the power of 9, well, that's just going to be 1. So in the end, we have 2 to the power of 0, which is just 1, plus 1, and that, of course, is 2. So number 1, the answer is C. What is the hundreds digit of 20 factorial minus 15 factorial? Well, both of these are multiples of 1,000. So they're going to have a whole bunch of numbers, and then they're going to end in 0, 0, 0. Now you say, well, how do you know that? So let me just write it out first. So when you take numbers that end in 0, 0, 0 and subtract them, whatever the result is will also end in 0, 0, 0, and then the hundreds digit is 0. But now I want to show you how did I figure that out, that these are multiples of 1,000. Well, for something to be a multiple of 1,000, it's got to have a 10, a 10, and a 10. You got to be able to extract 3 tens from it. Can you do that? Well, each of these tens is broken up into 2 times 5, right? So we have to be able to extract 5 3 times and 2 3 times. And I think I can do that. 20 factorial, well, you're going to be able to extract 2 from any even number. And there's a whole bunch of even numbers, so that's not a problem. The 5 you can extract from 5, 10, and 15. So you'll be able to get 3 5s. And when you combine those 3 5s and those 3 2s, you'll be able to get 1,000 when you multiply them together. And the same holds true for 15 factorial in the same way. So that's why I know that these numbers are both multiples of 1,000. They end in 0, 0, 0. When you subtract them, you get a big number that ends in 0, 0, 0. And therefore, the hundreds digit will be 0. Number 2, the answer is A. Anna and Bonita were born on the same date in different years, n years apart. Last year, Anna was 5 times as old as Bonita. This year, Anna's age is the square of Bonita's age. What is n? Well, A is equal to 5b. They tell you that last year, I guess. And then this year, we're 1 year more. So A plus 1 is equal to B plus 1 squared. This year, Anna's age is the square of Bonita's age. Okay, so I can sub this into this. And when I do, I get 5b plus 1. And this is what? B squared plus 2b plus 1. And put everything on one side, and we get b squared minus 3b is equal to 0. So factor out the b, and you get b minus 3 is 0. Therefore, b is equal to 3. It can't be 0, right? Because her age can't be 0. Well, I guess it could when she was born, but not later on. Okay, so now we have b equals 3. So that means a is 5b, which is 15. So 15 years of age is how old is Anita, and Bonita is a 3. So the difference in their ages is 12. So that means they were born 12 years apart. So number 3, the answer is D. A box contains 28 red balls, 20 green balls, 19 yellow, 13 blue, 11 white, and 9 black balls. What is the minimum number of balls that must be drawn from the box without replacement to guarantee that at least 15 balls of a single color will be drawn? So this is one of those extreme case scenario questions. You do something completely unrealistic, but that is what they're asking for. Let's say I withdrew all 9 of the black balls, all 11 white balls, all 13 of these blue balls. So all of these are gone. I still don't have 15 of any single color. So keep going. Extreme case, I withdraw 14 yellow, 14 green, and 14 red, doing it in such a way that I still don't have 15 of any one color. But at this point, the very next ball I draw has to be either red, green, or yellow, since these guys are all gone. And that next ball would bring one of those numbers up to 15. So for example, if I drew a yellow ball, it would bring this yellow total up to 15. So we have to figure out how many did we draw? Well, 9 plus 11 plus 13 plus 14 plus 14 plus 14. And that number is 75. So we can get to 75 without reaching 15 of any color. But the very next ball that you draw will guarantee that you have 15 of at least one color. And that one color will be either yellow, green, or red. And therefore the answer is 76. So number 4, that would be B. What is the greatest number of consecutive integers whose sum is 45? When you look at the answer choices, it goes up to 120. So that makes you think, that's much more than I originally thought. And that's because you got to take into consideration negative integers. So we start at negative 44, then add to it negative 43, then negative 42, and so on, right? Dot, dot, dot. Eventually you get to 0, and then you start adding negative 3, negative 2, negative 1. Let's just put that in there. And then once you get to 0, then you start adding positive. So positive 1, positive 2, positive 3, dot, 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 positive 42, positive 43, positive 44. Now, at this point, put in a positive 45. All of these guys cancel, right? Each one cancels the other one out. And at the very end, that 45 gives you a sum of 45. So now we have to figure out how many of these numbers are there. Well, minus 44 to minus 1, that's 44 integers. Then we have a 0. Then 44 to 1, that's another 44. And then we got this 45. So when you total up all those integers, there's 90 of them. So number 5, the answer is D. For how many of the following types of quadrilaterals does there exist a point in the plane of the quadrilateral that is equidistant from all 4 vertices of the quadrilateral? A square, a rectangle that is not a square, a rhombus that is not a square, a parallelogram that is not a rectangle or rhombus, an isosceles trapezoid that is not a parallelogram. The key to this question is to understand that anything that can be placed inside a circle will satisfy the condition. So let's see if I can fit in these guys. And the first one is a square. So let's see if I can put a square in here. I can. And it satisfies the condition as follows. The center of the circle will be equidistant from the vertices. And really what we're talking about is that the center to the vertice will be the radius of the circle. And there's a name given to these types of shapes, cyclic quadrilateral. I'm sure you've heard of that. And let me just illustrate that with one of these. So if I've got the center here and I draw a line, that's obviously the radius of the circle. If I draw another line to another vertice, another radii, and so on. So as you can clearly see, the square qualifies. So put a check mark there. How about a rectangle that's not a square? A rectangle that's not a square, can I put that? And the answer is yes, I can. So that also is good. A rhombus that is not a square. Very important that it's not a square. If it's not a square, what that means is that the sides are not the same. So it's going to be something like this. It'll be a rhombus, but it won't be a square. So as you can see, it'll fall outside the margins of the circle. So it won't be possible to do that. If it was a square, then you could, as I shown over here. So that one's no good. A parallelogram that is not a rectangle or rhombus. Well, a parallelogram is something like this, right? As I'm sure you know. Let me just draw it in. And as you can clearly see, that's not going to be able to fit inside a circle. So that's no good. And the last one, isosceles trapezoid that is not a parallelogram. Well, let's draw that over here. Isosceles trapezoid. Okay, so that basically means that two sides are the same. So let's make those two sides the same. And then here we go. Well, I fit it inside a circle. And this one is a little bit not as obvious, but it actually works out. surprisingly, that it actually does make a equidistant situation. So that one is a little tricky, but it does work. So it looks like of those three work for the conditions, and therefore the answer would be C for number 6. Two lines with slopes half and 2 intersect at 2, 2. What is the area of the triangle enclosed by these two lines? And the line x plus y is 10. Well, the first thing is let's create an equation for both of those lines. X over 2 plus b1 and y is equal to 2x plus b2. And then let's use the fact that both of them have 2, 2 to get the b1 and b2 values. So 2 is equal to 1 plus b1, so b1 is equal to 1. So that equation is x over 2 plus 1. Then let's do the same thing, substitute 2, 2 into this one. So you get 2 is equal to 4 plus b2, so b2 is equal to minus 2. So that is y is equal to 2x minus 2. Okay, so let's plot this now. For the first one, we have when x is 0, y is 1. And then when x is 2, y is 2, and therefore that's about here. So that's the first line. Next one, let's use that equation. When x is 0, y is negative 2. So approximately here, negative 2. And 2, 2, that's the one, of course, that they gave us in the question. So there we go. Now we got to look at that one. That is y is equal to 10 minus x. So let's plot that. When x is 0, we have y is equal to 10, so way up here somewhere. And when x is 1, it'll be exactly 9. So I guess I have to now connect the dots there. And when I do, it will look like this. So that is my shape, that triangle right here, this one. Now, what I noticed with these slopes is that one is 2, one is a half. So that means they're pretty much on either side of the line y equals x. Y equals x, of course, would be the one that's going right down the middle. So like this, right down the middle like that. And therefore, this line would chop that in half. And essentially it makes it an isosceles triangle. Makes it a little bit easier for us to figure out the area. Okay, so now I've got to figure out some coordinates. This one, and this one is already given. That's just 2, 2. Okay, so this one that we will find with setting 10 minus x equal to x over 2 plus 1. So that means if we multiply through by 2, 20 minus 2x is equal to x plus 2. 3x is equal to 18, x is 6. So this point right here is 6, and then substitute it back into either one of those, and you'll get 4 for the y coordinate. Now that coordinate we get by subbing or setting 10 minus x equal to 2x minus 2. And that would give me 12 is equal to 3x, so x is 4. So that point is 4, 6. Okay, so I can easily get this distance. That's just going to be using the distance formula. 6 minus 4 squared plus 4 minus 6 squared under the square root sign. So that's going to be 4 plus 4, so that's root 8, which is 2 root 2. And then this point is the midpoint of these 2 points. So you use the midpoint formula. 4 plus 6 over 2, 6 plus 4 over 2, and that gives me 5, 5 for this point right there. Okay, the last thing is just to figure out the distance from there to there. That's going to be the height of the triangle. Again, I can use the distance formula. That will be, 5 minus 2 squared plus 5 minus 2 squared under the square root sign. So that's 9 plus 9, and that would be 3 root 2. Okay, finally, we can figure out the area. 1/2 base times height. The base is 2 root 2. The height is 3 root 2. And therefore, this becomes the root 2 times root 2 is 2. That cancels with this 2. And then that would just be 6. So number 7, the answer is C. The figure below shows line L with a regular infinite recurring pattern of squares and line segments. How many of the following 4 kinds of rigid motion transformations of the plane in which this figure is drawn, other than the identity transformation, will transform this figure into itself? All right, let's talk about this. So, first let's talk about this statement here. Statement number 1, some rotation around point on the line L. So this is L right here, that line. Well, if you do a rotation, so for example, a 180-degree rotation about a point halfway between an up-facing square and a down-facing square, you will get the same figure. So this is a point halfway, this is another point halfway, and so on, right? Here's another point halfway between an up-facing square and a down-facing square. And if you rotate it 180 degrees all the way like that, it'll end up being the exact same. So number 1 is fine. Number 2, some translation in the direction parallel to line L. So we're basically going this way or we're going that way. If you translate left or right, you can put the same image onto itself. So you can just realign it. So a translation to the left or right will place the image onto itself when the figures above and below the line realign. The figure goes on indefinitely or infinitely in both directions. So we're going to move this to here, or we're going to move this to here, and it just realigns with itself. So number 2 is correct. Statement 3, the reflection across line L. So what they're saying is that you're treating the line as a mirror. Well, when that happens, this comes up here, and this comes up there. And that, although it may seem similar, it's actually not, because the up-facing squares become down-facing squares and vice versa. So it's not identical. Okay, so that means that one is wrong. That one doesn't work. Okay, so the last one is 4, some reflection across a line perpendicular to y. So now what they're saying is that the mirror is like this. So right down the middle. And at first you might think, yeah, it seems like the squares would be fine. And the answer is yes, the squares would be fine, but notice what happens to these little, whatever they're called, lines, I guess. Those little lines would not be the same. When you reflect it, it would look like that, and that obviously makes a different looking shape, a different looking diagram. The diagonal lines extending from the squares will switch direction, so that doesn't work. So that means of those 4, only 2 will be able to make the figure look exactly like itself, and therefore number 8, the answer is C. What is the greatest 3-digit positive integer n for which the sum of the first n positive integers is not a divisor of the product of the first n positive integers? All right, so let's talk about this. First, let's understand what it is they're saying. Let's just start with 995. So they're saying 995, if that was the answer, that when you do the product of the first n numbers, would be 995, 994, 993, and so on, right? All the way down to 1. A product, all the way down to 1. And that they're asking, is it divisible by the sum? 995 plus 994 plus 993, all the way down to 1, ... Well, let's see. The top one I'll leave alone for now, 995, and so on. But then the bottom one, that you can use that formula, which I'm sure you know. Sum of consecutive integers up until n is equal to n times n plus 1 over 2. So that becomes 995 times 996 over 2. So that is really just 995 times 996 divided by 2, which is 498. Like that. Well, let's see. Is this divisible? Well, 995 is in there, and a 498 will also be in there somewhere. So this is divisible. So this one is fine. We're looking for one that's not divisible. So that one's fine. Cross it out. So I hope you get the hang of this. Let's try the next one. 996. The product, of course, will be 995 and so on all the way down to 1. And then the sum using this formula will be 996 times 997 over 2. So that becomes 996 times 995 all the way down to 1. And then let's look at this one. 996 divided by 2 is 498. And we have 997. Well, 498 is fine. It'll be somewhere in there. That'll be divisible. But 997 is not. It starts at 996. And 997 is a prime, so you can't break that down either. So this one is not divisible. And you can go through the other three to convince yourself, but actually that is important to do because they want the greatest one. So now I would like to show you why this one is not correct. I'll let you do this one and this one, but this one, D, might trick a few people. So let's try 998. 998, the product, of course, would be 998 times 997 all the way down to 1. The sum will be 998, if we use this formula, times 999 divided by 2. So that is, of course, 998, the product, all the way down to 1. And we have here 499 times 999. Now you might say, okay, 499 will appear somewhere in here, but the 998, that doesn't appear here because that starts at 998. So this is the right answer, but it's not because 999 can be broken down into 333 times 3. And 333 will appear somewhere in there, and the 3, of course, will appear somewhere in there. So this is divisible. So that might be a little tricky, and therefore some people might choose D. But regardless, we have shown that the answer to this is B for number 9. A rectangular floor that is 10 by 17 is tiled with 170 1-foot square tiles. A bug walks from one corner to the opposite corner in a straight line. Including the first and last tile, how many tiles does the bug visit? Well, I don't expect you to draw the diagram on a math contest, but the solution is fairly straightforward if you know how to do it. It's a 10 by 17 grid, right? And both of those numbers are relatively prime. So that means that you're never going to hit the diagonal in between. So you see how I hit the diagonal at the very end, but in the middle, as I'm traveling, as the bug is traveling, it's never going to hit a diagonal because these two numbers are relatively prime to each other. You never get one as a multiple of the other. So as the bug is traveling, it has to cross edges. And if you look at the edges that are going horizontally, it's going to cross 1, 2, 3, 4, 5, 6, 7, 8, 9 edges until it gets to the very end. So there's 9 edges that it crosses in one direction. And then as it's going from one corner to another, it crosses a whole bunch of vertical edges, and there's 16 of those, as you can see, until it gets to the very end. So 16 edges. Every time, this is the key statement, each time the bug crosses an edge, it enters a new tile. And I hope this diagram can illustrate that for you. So since it's crossing 9 plus 16, which is 25 edges, it enters 25 new tiles. So here's the first tile it enters, second tile, third tile, fourth tile, fifth tile, and so on. So until we get to the last one. So all of those are shaded in. But don't forget where we started. We started here, so we have to add that one as well. So the 25 that we crossed into, and then the one tile that we originated from. So the total will be 26. So number 10, the answer is C.